The National Electrical Code, specifically Section 514, provides guidelines for classifying hazardous locations and gas stations. These classifications are based on the potential for flammable vapors to be present in the air. Understanding these classifications is crucial for selecting and installing electrical equipment, such as light fixtures, to prevent explosions and ensure safety. When dealing with a gas station that has one pump, the area around the fuel dispenser is divided into Class 1, Division 1 and Class 1, Division 2 zones. Class 1 refers to locations where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 signifies that the hazardous material is present continuously, intermittently, or periodically under normal operating conditions, or where it might exist frequently because of repair or maintenance operations or because of leakage. Class 1, Division 1 areas at a gas station extend within 18 inches, that is 450 millimeters, of any opening at the top of a fuel dispenser. They also extend within 6 feet, that is 1.8 meters, of the bottom of any opening in the fuel dispenser. This zone also stretches 20 feet, that is 6.1 meters, in any direction from the edge of the dispenser canopy. Class 1, Division 2 locations are those where the hazardous material is handled, processed, or used, but is normally contained within closed containers or closed systems from which it can escape only in the event of an accidental rupture or breakdown of such containers or systems, or in the event of abnormal operation of equipment. At a gas station, the Class 1, Division 2 area extends beyond 20 feet, that is 6.1 meters, from the edge of the dispenser canopy. It also includes the area within 10 feet, that is 3 meters, of the dispenser and within 6 feet, that is 1.8 meters, of the bottom of any opening in the dispenser. When selecting light fixtures for a gas station, you must ensure that they are rated for the hazardous classification of the location where they will be installed. For Class 1, Division 1 areas, you can only use explosion-proof or intrinsically safe fixtures. Explosion-proof fixtures are designed to contain any explosion that may occur within the fixture, preventing it from igniting the surrounding atmosphere. Intrinsically safe fixtures operate at such low energy levels that they cannot produce a spark or thermal effect sufficient to ignite a flammable mixture. For Class 1, Division 2 areas, you can use explosion-proof, dust-ignition-proof, or dust-tight fixtures. Dust-ignition-proof fixtures are designed to prevent the ingress of dust and to prevent the internal temperature from exceeding the ignition temperature of the surrounding dust. Dust-tight fixtures are constructed so that dust will not enter the enclosure under specified test conditions. While NEC 514 does not explicitly specify a vertical extent for Class 1, Division 2 areas, it is generally considered to extend up to the height of the dispenser canopy. This height is typically around 10 to 12 feet, that is 3 to 3.7 meters, above the ground. To illustrate, if you are installing light fixtures 30 feet, that is 9.1 meters, away from a dispenser and 8 feet, that is 2.4 meters, above the ground, the location would be classified as Class 1, Division 2. In this case, you would need to use fixtures that are explosion-proof, dust-ignition-proof, or dust-tight. In summary, firstly, understand the Class 1, Division 1 and Class 1, Division 2 classifications outlined in NEC 514. Secondly, select light fixtures that are specifically rated for the hazardous location where they will be installed. Thirdly, consider the vertical extent of the Class 1, Division 2 area, generally up to the height of the dispenser canopy. Adhering to these guidelines will ensure a safe and code-compliant lighting installation at a gas station. Let's further elaborate on the specific requirements and considerations for electrical installations in hazardous locations, focusing on gas stations with fuel dispensers. The NEC provides a comprehensive framework for ensuring safety in these environments, and understanding the nuances of its application is crucial for electrical professionals. We'll delve deeper into the characteristics of Class 1, Division 1 and Class 1, Division 2 areas, explore the types of equipment suitable for each, and address some common misconceptions. Class 1 locations are defined by the presence of flammable gases or vapors in the air, but the frequency and duration of their presence determine the division. Division 1 indicates a high probability of flammable substances being present under normal operating conditions. This could be due to leakage, spillage, or the regular transfer of volatile liquids. In the context of a gas station, the area immediately surrounding the fuel dispenser, particularly near potential sources of leaks or spills, is classified as Division 1. Division 2, on the other hand, signifies a lower probability of flammable substances being present. These areas are typically adjacent to Division 1 zones and are only expected to become hazardous in the event of an accidental release or equipment failure. The area extending beyond the immediate vicinity of the dispenser, but still within a defined radius, falls under Division 2. The selection of electrical equipment for hazardous locations is paramount. Not all electrical devices are created equal, and using equipment not specifically designed for hazardous environments can have catastrophic consequences. Explosion-proof equipment is designed to contain an internal explosion without allowing it to propagate to the surrounding atmosphere. This is achieved through robust enclosures and flame paths that cool escaping gases below their ignition temperature. Intrinsically safe equipment, as mentioned earlier, operates at very low energy levels, eliminating the risk of ignition. This approach is particularly suitable for instrumentation and control circuits. Dust ignition-proof equipment is designed to prevent the ingress of dust and to ensure that the external temperature of the enclosure remains below the ignition temperature of the surrounding dust cloud. This is crucial in environments where combustible dust is present, such as crane elevators or coal handling facilities. Dust-tight equipment, while not specifically designed for hazardous locations, can be used in certain Class 2, Division 2 areas where the risk of dust accumulation is minimal. However, it's essential to verify that the equipment meets the specific requirements of the application. One common misconception is that all explosion-proof equipment is created equal. Explosion-proof equipment is designed and tested for specific gas groups and temperature ratings. The gas group indicates the type of flammable gas or vapor that the equipment is designed to contain, while the temperature rating specifies the maximum surface temperature that the equipment is allowed to reach. It's crucial to select equipment that is rated for the specific gas group and temperature class present in the hazardous location. Another misconception is that simply installing explosion-proof equipment is sufficient to ensure safety. Proper installation is just as important as selecting the right equipment. Explosion-proof equipment relies on precisely engineered flame paths to cool escaping gases. If these flame paths are damaged or obstructed, the equipment may not function as intended. It's essential to follow the manufacturer's instructions carefully and to ensure that all connections are properly tightened. Grounding and bonding are also critical aspects of electrical safety in hazardous locations. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker and energizing the circuit. Bonding ensures that all metallic components are electrically connected, preventing the buildup of static electricity, which can be a source of ignition. Regular inspections and maintenance are essential to ensure the continued safety of electrical installations in hazardous locations. Inspections should be performed by qualified personnel who are familiar with the requirements of the NEC and other applicable standards. Maintenance should include checking for loose connections, damaged enclosures, and any other signs of deterioration. It is important to consider the specific conditions at the gas station when determining the extent of hazardous areas. Factors such as ventilation, the type of fuel dispensed, and the frequency of refueling can all affect the concentration of flammable vapors in the air. A qualified electrical engineer or hazardous location consultant can perform a risk assessment to determine the appropriate classification for each area of the gas station. The NEC provides specific guidelines for wiring methods in hazardous locations. Conduit systems must be sealed to prevent the migration of flammable gases or vapors from one area to another. Fittings and boxes must be explosion-proof and properly sealed. Cables must be specifically listed for use in hazardous locations. The NEC also addresses the use of flexible cords in hazardous locations. Flexible cords are generally not permitted in Division 1 areas, except for specific applications such as portable lighting or equipment. In Division 2 areas, flexible cords must be of a type approved for the location and must be protected from physical damage. Lighting is a critical aspect of safety in gas stations. Adequate lighting is essential for workers to perform their tasks safely and efficiently. However, lighting fixtures can also be a source of ignition if they are not properly selected and installed. Explosion-proof lighting fixtures are required in Division 1 areas. These fixtures must be designed to contain any explosion that may occur within the fixture and to prevent the escape of flammable gases or vapors. In Division 2 areas, explosion-proof, dust ignition-proof, or dust-tight lighting fixtures can be used. Emergency lighting is also essential in gas stations. Emergency lighting must be powered by a separate source of power, such as a generator or battery, and must be capable of providing adequate illumination for at least 90 minutes in the event of a power outage. Signage is another important aspect of safety in gas stations. Signs must be posted to warn of the presence of hazardous materials and to provide instructions for safe operation. Signs must be clearly visible and legible, even in low light conditions. Training is essential for all personnel who work in gas stations. Workers must be trained on the hazards of flammable materials, the proper use of equipment, and emergency procedures. Training must be provided on a regular basis and must be documented. The NEC is not the only standard that applies to electrical installations in hazardous locations. Other standards, such as those published by the National Fire Protection Association, the American Petroleum Institute, and the Occupational Safety and Health Administration, may also be applicable. It's important to be familiar with all applicable standards and to comply with the most stringent requirements. It is worth noting that technology is always advancing, and newer methods of mitigation may be developed. Always consult with a qualified professional on any work being performed to ensure compliance with all local, state, and federal regulations. For example, there are many different types of explosion-proof boxes that exist, and using one type versus another may be more applicable based on the work that is being performed. The selection of a light fixture involves a lot of different aspects of compliance, and you can't just buy any explosion-proof box. There are many different gas groups that may need to be accounted for, and each gas group is going to have different specifications on what is and isn't allowed. It is always recommended to have a professional inspect the install before and after it is completed to ensure everything is in line with the current applicable codes and standard. Remember to consider that changes to the NEC occur on a 3-year revision cycle, and amendments may be made by the local governing municipality as well.